IP address is at the center of some or most of the things you'll be doing. Are you a software engineer, cybersecurity, someone in networking, cloud computing, or DevOps, or just a regular user of the internet? You really have to understand IP addresses because without an IP address, you will not be able to interact with the internet. An IP address or Internet Protocol address is a unique identifier that identifies every device on a network connected to the internet. Just like a Google pin will be able to tell your location and how people can find you physically, a public IP address does the same thing. It tells online services, websites, and other devices on a network on the internet how to find and communicate with your device. An IP address looks like this. This is the most commonly adopted version called the IPv4 IP address. If you want to know what your current public IP address is, you can just simply Google what is my IP address, or you can check by visiting the website www.whatismyip.com. You will also see the city and the internet service provider. Though this IP address can change over time due to various factors like when you change your location or change your network or when you restart your device or router. I'll talk more about this later in the video. Basically, an IP address serves two major purposes. One, it provides an identity for your device, or more accurately, your network interface on the internet. Secondly, it provides a location for your device, allowing data to be routed to you. Whenever we access the internet from our homes or workplace, internet service providers or ISPs like MTN, Starlink, and so on assigns an IP address that is publicly registered on the internet to our device's router or modem. Because without these public IP addresses, we cannot access the internet. This is what gives us access to the World Wide Web. These ISPs purchase lots of these public IP addresses and assign to their customers. Public IP addresses are unique to every user on the internet. There are no duplicates anywhere in the world. When these IP addresses were first created by the engineers, even if there are over 4 billion unique addresses, these engineers did not realize how big the internet will become. And so because of this massive adoption of these unique public IP addresses, there was shortage. So these engineers had to come up with the IPv6 or the IP version 6 IP address to satisfy this growing need of public IP address on the internet. So how does this IP version 6 compare with the popular and commonly used IPv4? So this is what the IPv6 looks like, and this is what the IPv4 looks like. First of all, in terms of structure, the IPv4 has a 32-bit structure consisting of 4 blocks or groups called octets, separated by dots or periods. Each octet is composed of numbers between 0 and 255 and holds 8 bits. This entire structure makes the IPv4 capable of about 4.3 billion unique IP addresses. IPv6, on the other hand, has a 128-bit structure consisting of 8 blocks or groups called hex states, separated by columns. Each hex state is composed of alphanumeric characters between 000 to FFF. This allows for about 2 to the power of 128 unique IP addresses, which is much more higher than that of the IPv4. Take note that the IPv6 can be compressed to look like this. The beginning zeros can be omitted, but the ending zeros cannot be omitted. This upgrade with the introduction of IPv6 accounts for more unique IP addresses, increased security and efficiency in data transfer, though IPv6 is slowly being adopted by more users. There are two major types of IP address: the private IP address and the public IP address. First, I'm going to start by talking about the private IP address. To check for your device IP address, if you are on a Mac or Linux machine, head on to your terminal or command prompt and type ifconfig, and you would see your private IP address of your device. But if you are on a Windows system, type ipconfig, then you will see your private IP address of your device. When devices are connected locally over a network, either via a wired connection or they are connected wirelessly via the use of router, every device on that network is assigned a private IP address by that router through DHCP server in the router. DHCP stands for Dynamic Host Configuration Protocol, and that is responsible for assigning unique private IP addresses to these devices. These addresses are only used internally in your houses or in your place of work, and they do not give you access to the internet because these IP addresses are not registered on the internet. So it can only be used to communicate between devices on that network internally. In order for you to be able to access the internet, your private IP address has to be translated to a public IP address. When you order internet service from internet service providers, they assign your device or router a public IP address which you can use to access the World Wide Web. Your private IP address is being translated into a public IP address that the internet recognizes. And this translation from private IP to public IP is done by a service known as the Network Address Translation Service. This service is responsible for translating a set of IP address to another set of IP address, either from a public IP address to a private IP address or from a private IP address to a public IP address. Building on this knowledge and based on what I said earlier about reassigning of IPs by ISPs, it is important to know the difference between a static IP address and a dynamic IP address. Static IP addresses are fixed and do not change over time. They are manually assigned to a device by an administrator and remain constant, making them ideal for hosting servers and running services where consistency and stability of IP is crucial. On the other hand, dynamic IP addresses are automatically assigned by a network when a device connects and can change over time. This process is managed by the dynamic host configuration protocol available in these devices like router. Just like I have mentioned earlier, they are responsible for assigning IPs to different devices. Understanding the difference between a static and dynamic IP address is essential for configuring network and ensuring stability and efficient connectivity. Static IP addresses are preferred for applications and services needing constant access points, while dynamic IP addresses are practical for general use, where ease of management and cost savings are prioritized. Static IP addresses are mostly required and used by most of the applications we use online. Most sites, applications, and services we use regularly have these static IP addresses running behind them. Since it's very difficult for most users to memorize these IP addresses since they are just numbers, a domain name is being assigned to these IPs by a domain name service provider. Dynamic IP addresses are useful to internet service provider. A new public IP address is assigned to your device or router anytime you disconnect from the internet and come back. Though there is a probability of getting the same public IP address as before, but only if another user on the internet has not been assigned that IP address. Take note, a private IP can be static or dynamic. A public IP address can also be static or dynamic. In a local environment, like in your house or workplace, where every device connected on a particular network is private, there are some devices that might need to have a static IP address due to some of the reasons I mentioned earlier. You might need to contact your network administrator or your engineer to assign a static IP address to that device so that whenever that device is connected on a network, it maintains the same IP address. For public IPs, since they are assigned by internet service providers and other entities, you might need to reach out to them to assign a static public IP address so that even if you disconnect and then you come back to the network online, the same static public IP address is given to you. Otherwise, a different dynamic public IP address will be assigned to your device. Everything I've just said about IPs, private IPs, public IPs, static IPs, dynamic IPs, and routing are not just applicable to just your local environment, your house, your homes, and how they interact with the internet. They are also applicable in the cloud environment. Say whenever you host your web servers, your website, your database on cloud platforms like AWS, GCP, and Azure. There are scenarios where you might need your servers and database to be on the same network, each service having its own private IP address and sharing resources with each other. You can set up firewalls and take up other security measures so that users or attackers do not have direct access to these resources. When you make your application publicly available to the internet, you might choose to make it publicly available to everyone with internet access, or you restrict access of users based on their geographical locations. You can also make it available to only specific users by whitelisting their public IP address, or you can restrict some some users by blocking or blacklisting their public IP address as well. So having said all this, I'm sure you now have a basic understanding of IP addresses, what they are, and the different types. If you really did enjoy this video, please don't forget to subscribe because I will be feeding you more interesting content like this. And if there is any question you have about IPs or there is any confusion, please feel free to hit me up in the comment section as I'll be keeping an eye there and answering every possible questions to clarify any confusion. Thank you. Don't forget to like, share, and subscribe. See you in the next one.